Hi everyone, this is the first video for section 7.4 on percents. So just like always, if you haven't at this point, go back and make sure that you've read through the section on percents. So percents this whole section is pretty much an application of decimals and proportions. And so this is really, like I said, it's really a whole section about applications and how we use these things and why they're useful. So first off, let's talk about what is a percent. So a percent is a part to whole ratio where the whole is 100. So this is something that you all should have seen before, so we're just going to go over it just to make sure that everybody's on the same page. So a percent is just a part to whole ratio where the whole is 100. So when we use the percent symbol after any number, we're indicating that we mean a ratio of that number to 100. So, for example, 24% is equal to 24 over 100. And so, because 100 is a power of 10, it's really easy to convert this to decimals. So we can see that 24% is equal to 24 over 100, and we know that we can convert that to 0.24. Okay, so by definition, a percent is a fraction. It's a ratio, and we represent ratios either by fractions or the colons or the words. So by definition, a percent is a ratio. However, we often think of it using a decimal. So it's important just to make sure that your students know that the definition of a percent is a ratio. Just because we convert between these things really frequently, just make sure that you know what the actual definition is. Okay, so like I said, we convert between these three things a lot. So there's a lot of examples of this on page 277 of the book, example 1 and example 2. Again, this is something that I expect that you've seen before, so we'll just go through a couple quick examples. So we want to write the fraction 13 over 10 as a decimal and a percent. So first of all, we're looking at 13 over 10. So if we're converting a fraction to a percent, remember a percent is just a fraction where the denominator is 100. Right, part to whole ratio where the whole is 100, that just means a fraction where the denominator is 100. So we can convert this denominator to have this denominator of 10 to a denominator of 100 pretty easily, just multiplying by 10 over 10, where 10 over 10 acts as our 1, our multiplicative identity. So this is 130 over 100. And so that is 130%. So if we have a fraction where the denominator is 100, to get the percent, you just take the numerator of that fraction. And then we want to also convert this to a percent. So you can do this in a lot of different ways. This is something that we can do this in a lot of different ways. So one way we can do it is just dividing 13 divided by 10. 10 goes into 13 one time. With 3 left over, we can add a decimal here, add a decimal here, carry the 0 down, and we get 30. 10 goes into 30 3 times. So as a decimal, this is 1.3. Or equivalently, we can write it as 13 over 10 is 1 and 3/10 using mixed number. And we know that 3/10 is 0.3. So this is just 1.3. So you can do it in either of these ways. Just make sure that you always show your work. There were a lot of people who got points off for that on the second exam, so make sure that you always show all your work. Even though, yes, we can just look at 13 over 10 and immediately write it as 1.3, make sure that you're showing me that you've learned these strategies. A lot of this class, because this is a class for future educators, is making sure that you know how to show all of the steps so that if you teach students, you show all the steps to them later on. So just get in that habit now. Okay, the next one, part B, says write the percent 37% as a fraction and a decimal. So 37%. And so based on our definition of a percent, we just take the number in front of the percent sign and put it in our numerator as a fraction over 100. And then we know how to convert this to a decimal really easily. This is 0.37. Okay, so these were just a couple quick examples. Like I said, you should have seen something like this before somewhere. Okay, so now the main part of this section is the applications. So for the percent problems. So the first type of percent problem we're going to talk about is the basic percent problems. So these problems use what is called the percent equation. So this equation here is called the percent equation. So that's the percent equation. And so it's just an equation where A represents the whole, B is the part. Ooh, never mind. Sorry, that was backwards. So A is the part, P is the percent, and B is the whole. So we just have a part equals a percent of the whole. And that makes sense with how we've continuously thought about fractions in this way. So another setup of this problem is this equivalence of fractions. So we have our part over our whole, our A over our B, and then our percent of 100, where this makes sense with how we think about percents as a fraction over 100. And we can also set it up as this equation to find equivalent fractions. And remember, this was stated in some of the previous videos, but on the second exam, I saw a lot of cross multiplying. And remember that in this course, we are never going to use cross multiplying because it's really confusing if you don't know what you're doing with it. So to solve this, we're never going to use cross multiplying. If you put this on an exam, you will get no credit. Okay, so let's work these examples that use the percent equation. So the first example says 536 is what percent of 670? So we need to identify our A, our P, and our B in these examples. So our part, our whole, and our percent. So 536 is what percent of 670? So 670, based on this context, is going to be our whole. We're looking for the percent P, and that means that 536 is our part. Okay, so we can set this up using either the equivalence of fractions or just the standard percent equation. So I'm going to do it using the standard percent equation. So when we set this up, we have our part equals P times our whole. And so to solve for P, we just divide by 670 on both sides. So 536 over 670 is P. And so to simplify, we can do a lot of different things. You can find the factors of 536 and 670 using the factor tree and then see how they cancel out. You can, essentially just simplify it down until you get something. And so that's how to simplify it just using the fractions. Or you can, now that we are in chapter 7 and we can talk about decimals, or you can just divide it into a decimal. So remember to convert a fraction to a decimal, you just do the implied division that's there. So 536 divided by 670. So because 536 is less than 670, we're going to have to add a decimal here. And let's think about what this number, how many multiples? How many multiples of 670 can go into 5,360? So it's not 10, because 10 multiples of 670 is 6,700. 9 still seems a little bit too big because 9 times 6 is 54. So let's see what happens when we do 8. So you can do this using some scratch work. I'm going to do some scratch work up here. So 670 times 8, 8 times 0 is 0. 7 times 8 is 56. And then we have 6 times 8 is 48, plus 5 is 53. And this is exactly the number that we were looking for. So 8 times 670 is 5,360. So we have a remainder of 0 here. So this tells us that P is 0.8. Let me fix that equal sign a little bit. So this tells us that P is 0.8. So this is our P as a decimal. So if we were to write out a final answer for this in a complete sentence, we would see that 5/36 is 80% because we convert 0.8 to the fraction 80 over 100, which is 80% of 670. And this is our final answer. Okay, so now for the second one. Again, we want to identify what is our part, what is our whole, and what is our percent. So the percent is probably the easiest one to identify. So that's 6% here. And we want to say that 12 is 6% of what number? So the of tells us there's an implied multiplication there when we see of, and we see that our percent is multiplied by our whole. So 6% of the whole, which tells us that 12 is going to be our part. So just to show you both ways of solving these problems, for this one, I'm not going to use the percent equation as it is, but I'm going to use the equivalence of fractions. So we can set up this ratio as 12 over b equals 6 over 100. Write our part over our whole, and equals our percent, which is 6%, which becomes our numerator and our fraction over 100. So remember, we are not going to cross multiply to solve for b here. We're going to have to do something else. So 6%, we're just going to convert this fraction over here on the right. So 6 is a really nice number that we were given in this problem because we can just multiply this by 2 over 2, which acts as 1, our multiplicative identity, which gives us 12 over 200. And, well, just by seeing that, we can see that clearly that b is 200. So that's all we needed to do. So then our final answer is that 12 is 6% of 200. And that's how you do it. So this is just the basic percent problems that are just using the percent equation. So that's what's mostly covered in the book, is using this percent equation. However, I also want to talk about percent increase and decrease, so we'll start talking about that in the next video.